Hey, Kelsey. I did not get your email until after class was over, and so I'm going to go ahead and just kind of go through what we talked about in class. I gave everybody else a note card and told them to write down kind of the stuff that you see on the screen here. And that kind of goes along with rational functions here. So I gave him this example, and I said that we were going to fill out each one of these three things: the x-intercept, the holes, the vertical asymptotes, the domain. Okay, so I'm going to go through this kind of fast. If you need to pause this video to write anything down, go for it. The x-intercepts, I said we plug 0 in for x, or excuse me, plug 0 in for y. So when we plug 0 in for y, we have this stuff here, but then if you multiply the x squared plus 4 to the other side, it's really just kind of like setting the numerator equal to 0, which is this part here, okay? So if I set the numerator equal to 0, x equals 2, that's going to be what my x-intercept is, okay? For holes and vertical asymptotes, you both do the same thing. You set the denominator equal to 0. And so we have x squared minus 4 equals 0. That's this part right here. And x squared minus 4 is a difference of squares, so x plus 2x minus 2. But the only difference is that for a hole, the top and the bottom will factor out, but for a vertical asymptote, the bottom and top do not cancel out. So when we factor that difference of squares, the x plus 2x minus 2, what we notice is that this x minus 2 up here and this x minus 2 down here, those cancel with each other. So x equals 2 is actually a hole, but x equals negative 2 is a vertical asymptote because he did not cancel out, okay? And then both of those things combined, the hole and the vertical asymptote together, kind of combine to tell us what the domain is. So since there's holes and vertical asymptotes and funny business happening at 2 and negative 2, that means x can't be 2 and x can't be negative 2. Because if we think back to the function, if we had 2 and negative 2, and we plugged those guys in, we would end up with 0 in the bottom. And we can't have division by 0. So that was just kind of some information for that function. I went ahead and did some different examples when we're talking about horizontal asymptotes. So a couple things to remember about the HA is that n is the degree of the numerator and m is the degree of the denominator. And we kind of search for those two things when we're looking at a function here, okay? So rule number 1, if n is less than m, y equals 0 is your HA. So I use this as an example. For the numerator, my my degree is 1. Denominator, my degree was 2. So n and m were 1 and 2. And n is less than m, so y equals 0 is where the horizontal asymptote is going to be. Okay. For the second example, if you have an n and m the same, like we had n is 3 and m is 3, for this example, we use the leading coefficients, the numbers out in front, so 1 and 3. So y equals 1/3 is going to be my horizontal asymptote. Okay. Then for number 3, n was 2 and m was 1. The degree of the numerator and denominator, and since n was greater than m, this is going to not have a horizontal asymptote. And what he has instead actually is a slant asymptote, because the numerator is 1 degree larger than the denominator. To find a slant asymptote, we use long division, and we use like the first little bit, everything except the remainder for long division, to find the slant asymptote. On the test, I am not going to give you a slant asymptote. I only give you horizontal and vertical asymptotes. So, you don't have to do that slant asymptote or the long division to find the slant asymptote. But I just kind of wanted to put that note in there, is that if you have a horizontal asymptote, or if you don't have a horizontal asymptote, a lot of times you will have a slant asymptote. Okay? So if you need to pause that, go ahead and finish filling that in. Then I scanned MJ's, he put his name on his paper, but this is the review. And so we kind of talked about a couple things here on the review. They wanted me to start with number 3. So what is the remainder when you're taking this guy and you're dividing by x minus 1, okay? And if you were to actually divide this by long or synthetic division, you would have like a bunch of zeros in the middle here, like x to the 112th power. You would have 0x to the 111th, 0x to the 110th, and all of those all the way through. And that would be really, really, really long and ugly to divide out. But we have a special kind of cool rule that says that if I take x minus 1 and I set it equal to 0, then x equals 1, and then I can just take that 1 and plug it in. And when we plugged it in, we got 0 as an answer, which means that if I would actually divide it out, I would get 0 as a remainder, okay? just in addition to that, if 0 is my remainder, then that means x minus 1 factors into this guy perfectly, okay? So that was just kind of another cool feature about that, okay? We went through example 4 real quick too. It said my zeros were 3 and 2i, and we said that means that x equals 3 and x equals 2i, but if you have an imaginary 0, then that means his conjugate is also a 0. So x equals negative 2i is another one as well. So that means we have these 3 guys as factors. And when you have imaginary numbers, you always want to multiply the conjugates together first, because those middle 2 pieces are going to cancel out with each other, okay? And that makes it really nice. So when you multiply those together, we get x squared plus 4, and then we FOIL that with the x minus 3, and we get this as our polynomial function, okay? So that was another one that we kind of did in class together. And then they wanted me to start setting up number 1, the synthetic division. So when you're synthetic dividing, you set what you're dividing by equal to 0. So that means 2 is my number on the outside here. And then I want to put my coefficients out in front. So x to the 6th power has a 1 in front of it. So I would start with 1. Let me go to a thing that you can actually see. 1. Make sure you put the negatives with them. Negative 5, 8, 1, negative 17, 16, negative 4, okay? And the only other thing that I will tell you is make sure that when you're going through there, make sure you put zeros in if you need to put zeros in. Okay, this one I don't think we do, because we have an x to the 6th, 5th, 4th, 3rd, 2nd, 1st, and then we have a number. So we are okay, we don't have to put any zeros in, and then you just go ahead and do your synthetic division like you would normally, okay? A little hint here, number 1, you should have no remainder. Number 2, though, you will have a remainder. Okay, and it's kind of a yucky remainder. And number 2, you will need to put zeros in. You have to have a 0x squared plus 0x, and then also what you're dividing by needs to have a 0x in there as well. So that was another thing that I was kind of walking around helping kids, because they wouldn't put those zeros in, and then it got all messy. Okay, so we're going to continue working on this review tomorrow. You can, log on if we have technical issues. I guess we'll figure that out tomorrow. As if you have that happen, you can email me, and I can kind of go through some things with you. But the rest of the kids just continued working on this review, and we will probably test on Wednesday. I know that they are shortened periods because of the late start that's scheduled on Wednesday. But I think that's what we're going to plan on for now. Okay. Let me know if you have any questions. Email me back if you have anything. And we'll see you tomorrow.